Hi everyone! In this video, we will compute the z-value for one population mean with the known standard deviation. A nutritionist claims that a new diet plan reduces the average daily calorie intake of participants below the national average of 2,500 calories. To test this, a sample of 40 participants following the diet plan is taken, and their average daily calorie intake is recorded. Determine the critical value for a one mean z-test at the 5% significance level if the hypothesis test is left-tailed, where the alternative hypothesis is that mu is less than 2,500. The alternative hypothesis was given to us, but let's go ahead and write down the null hypothesis just for practice sake. The alternative is that the mu is less than 2,500, and we were also told that the national average is 2,500, so this is where the average equals 2,500. The alternative hypothesis is the one that decides which tail of a test we need. This has a less than sign which points to the left, and also the word less than indicates that we are using smaller numbers, and so it is a left-tailed test. Let's go ahead and draw a normal curve and show that we are doing a left-tailed test. So we are interested down here. And we were told that we are using a 5% significance level. This means we are looking at the bottom 5% of our normal curve and changing this to a decimal so that we have the area under the curve makes this 0.05. Our goal is to find the critical value or the cutoff right here for the bottom 5%. We have several ways of finding that. The first way is we can estimate this with the empirical rule. We could also use a calculator. However, in this case, we were given a chart and we can use it instead of trying to calculate it all on our own. We were given the 5% significance level, so we're going to go over here to our chart and find z sub 0.05, giving us a critical value of 1.645. Let's go ahead and draw our mean right down the middle. The mean is 2,500. And this critical value is a z-score that tells us that it's a certain number of standard deviations away from the mean. And we were given 1.645. This means it is 1.645 standard deviations from the mean. However, we are doing a left-tailed test. That means that we are moving to the left or in the negative direction of standard deviations from the mean. So this is 1.645 standard deviations to the left, meaning it's negative 1.645. So our critical value is negative 1.645. And now we're all done.